Okay, test. That should be live. Hello, everyone. Welcome to one more day of the compiler project. So, today, last we left off last week, on Thursday, I was working on finishing some of the AST things. Specifically, on Thursday, we worked on adding tests to the AST, since we were arriving at the point where we could start testing things. However, on Thursday I was tired, and one of the last tests I was working on was not working, and I was taking a few shortcuts to try to make it work, and I am not happy about that. I have the chance of being able to work on a project that has no deadline, so I would rather take the time to do things proper rather than trying to take shortcuts because there's no market I'm trying to corner and I'm trying to rush to. My only goal with this project is to try to keep the streams entertaining. So, I think today we're gonna start by fixing the things that were broken last time. Specifically, we were trying to do a test where we generate an arbitrary AST, we pretty print it, we pass it again, we pretty print it again, and we check that we arrive at the same result. As in checking that all of those moving parts work together correctly. Which means testing a bunch of different things because the goal is to test the parser and the AST representation, but doing so implies also testing the pretty printer and the arbitrary AST generator. So trying to debug this requires a bit of work. So let's get started. So the main thing I want to do, one thing that I did wrong last time and I want to fix, we found a bug that was caused by the arbitrary AST generation generating something that is not possible. And instead of fixing the fact that it was possible to represent something wrong in the AST, I changed the generation. And that's not the right solution for this. So let's start by fixing this. Specifically, this was, if I remember correctly, in one of the expressions, I don't remember which one it was. We're generating an arbitrary thing. There we go. Here. Why are we doing this? I'm not sure why this is correct, actually. I think it was for a function call. There's one where we changed the representation. We changed the arbitrariness. Which one was it again? Was it a function? No, it was a reference expression. That's what it was. Because here, a reference expression is an arbitrary. What's in the AST? Yeah, here, no, it is a path info. That's correct. Huh, so I don't remember what was wrong. Well, we'll figure it out. There was something like this where the representation in the AST was too general and we changed it. And it seems to be the negation, but I'm not sure why that is. I wonder if it's because a negation can only happen... No, it can happen before any expression, I think, as far as I remember. Negation expression. Yeah, it could be before any expressions. That's not that. So here, this should be able to be any arbitrary location. So I don't remember what was wrong with that. We'll figure it out. The main thing I want to do, however, is here I have in this file all of the arbitrary instances, which allow me to generate an arbitrary AST, whatever it is, any arbitrary of those values. I want to change that. And specifically what I want to do is I want to help QuickCheck, which is the thing I'm using this thing with, give me like tests that break. So what QuickCheck does is I give it a property, like for all arbitrary values of this type, this property should hold, and it generates a bunch of arbitrary values for that type and checks that it passes the property for all of them. And however, there's a second part in the arbitrary generation, which is how do I shrink a value? As in, I have a value that happens to break the test. How do I find the smallest possible test case that actually breaks? And that's basically how do I reduce a value to like smaller components? And at the moment, for none of those types, I have given a way to I have given a way to reduce to shrink a breaking test case to a smaller test case, which means we have error messages that are absolutely gigantic. So let's start with this. That's an important bit to try to make our tests a bit more reliable. So how do we shrink? Let me first have a look at what this looks like. This would be not here, but here. So shrink, given a value of my type A, gives me a list of values of the same type, as in the other smaller possible values from that starting value. So here for a module, where we have a module which is a list of imports and a list of declarations, it's going to be basically trying all subsets of each of them, I guess. So how do we do that? Because I suppose, what's the implementation of shrink on a list? Let's have a look. Let's have a look at how shrink is implemented for a list. I know there's a few shrink helpers we can use. Generic shrink is not what I want. Shrink list, I don't think is correct. Okay, so let's see what the implementation of arbitrary for lists is and see if we can use that as an inspiration. Because I think there must be an implementation of arbitrary for lists. Oh, this is co-arbitrary. There we go. That's the one I was looking for. If we look at the source, instance arbitrary, shrink 1. Okay, what is shrink 1? Lift, shrink. Okay. That is useless. Unless lift shrink is actually useful. No, it doesn't seem to be. Okay. That's a bit annoying. I was expecting it to be better than that. So let's think about it. What's all the subsets? I think there was a subterms function in this that we can use. But it seems to be... Okay, no, it is not. Huh. Well, the thing is, if something is broken, it's unlikely to be caused by the juxtaposition of several use cases, import statements or declarations. Therefore, we should be able to reduce to modules that only contain one of each statement. That's probably fine. Okay, let's try that instead. So if I want to shrink a module that contains use statements or imports and declarations, what we're going to do is we're going to do a list of modules that only contain, so let's do that. It's going to be 2 lists. The first list is going to be for each import in, well, in the imports, and we're going to create a module that contains that import and no declarations. And the second list is going to be for each declaration in the declarations. Make a module with no imports and just that declaration. Okay, that way we reduce each module that has been arbitrarily generated to just like one thing that might break, which is going to reduce the amount of stuff in our debug values. Now, how do we reduce an import? How do we shrink one? I'm gonna remove this and put this instead. To have a look at what we have. Is this big enough on the stream? That looks big enough. Let me know if it's a bit too small. An import is a path and an import type. We cannot really reduce the import type, I guess. I guess we can try shrinking it here. So how do we shrink an import type? That's really gonna depend if it's qualified with maybe an identifier. There isn't really anything we can change. We can try, actually. I guess we can try returning qualified. Actually, it's just going to be a value here. Well, we want to do that if it's... So if there was, we can try returning qualified nothing. If it was qualified, I think we need to return a list. There we go. If it was qualified nothing, we can return the empty list. There's nothing we can shrink further. If it was exhaustive, we can return an empty list. There's nothing we can return further. Actually, we can just make a catch-all case here at the end. And however, if this was a specific list of identifiers... Oh, I was thinking maybe we should have... No, okay, it's... Do we want to have... Because if here shrink is never going to terminate, there's never going to be a point where we're going to not be able to reduce any further, and I don't think that's correct. Let me just quickly check the documentation for shrink. Like, does it need... Yes, shrinking will go into an infinite loop. We need to make sure that it always reduces, which is not the case with our current implementation. Okay. So that means here we need to check... So here, let's add more cases. If we are in a case with one element and an empty list, then we return the empty list. Likewise, if there's only one element in either list, we return the empty list. And actually, we should also do that in the case where both lists are empty. So there's nothing, we don't reduce any further if... I guess actually that's not true. In the case where there is something, there's one element left, we can shrink one step, which is to return a list with nothing in it, a module with nothing in it. I don't think that's useful, but that's technically correct. Okay, next. So here, if it's specific and it's a list of identifiers, if the list is empty, then we need to return an empty list. There's nothing to shrink any further. Otherwise, if it's specific of a list of value, I'm surprised that the shrink doesn't work on lists. I think it might, I must have read it wrong. I'm sure it works. I think we could just try it actually. Import test quick check. So we need to set, let me just do that and that. Okay, let's try again. Huh. I guess it's because I'm not in test mode in GHCI. Okay. Okay, so what I want to try is if I have a list of 3 integers. Ah, what do you mean not in class int? What is happening? There we go. Okay. Okay, no, shrink works on lists. That's reassuring. And if I try on this, okay. And if the list is empty, what does it do? Okay, it returns an empty list. So that means I can rewrite this to instead shrink of a module here is gonna be applying the module constructor to shrink of the imports and shrink of the declarations, and it will do the right thing. Okay, so here specific ideas is going to be applying the specific constructor on each element of shrink of the IDs, which means I don't need to handle this case specifically. There we go. Oh, I can probably do the same thing for... What does shrink of just for maybe int? Okay, it tries to shrink the value within. That makes sense. And I'm assuming the shrink of nothing and maybe int will just return an empty list as well. Okay. So likewise here, I don't have to handle this case manually. Perfect. I can just delegate to shrink here as well. And return qualified of shrink of the maybe identifier. And now anything else, the only case left is exhaustive. And there's nothing to reduce here. So this would be returning the empty list. Okay. Now we can go back to import. Actually, I'm not sure how... I don't think there's... Since there's no arbitrary instance for text, I guess I could reduce my identifiers by transforming into string and then shrinking that. That feels a bit inelegant, but it will probably work. Or I guess I could just return a list of like just return one element, which is removing the first character. That feels a bit ugly. Okay, well, for now, let's do that. So I'm shrinking an import, which is a non-empty list of identifiers and an import type, both of which should have a arbitrary instance and therefore should have an implementation of shrink. So it should be possible to just say path and type. I should be able to do that as import of shrink the path and shrink the type. For an identifier, I think I'm gonna do this the ugly way, I think, which is gonna be to do convert the text into a string, which is a list of characters. Well, of Haskell characters and therefore Unicode code points. Do a shrink on that list and map back, which remakes it a text back on every element of the list. It's a bit ugly, but that will work. We've done the shrink here. Now, here, I think since this is an enum case that delegates to an info type, I'm gonna do the thing where I simply delegate the responsibility of shrinking to the actual info type. So, I can just copy this, I guess. Oops. There we go. So assuming that all of the information types have a shrink implementation, which all have by default, but we're going to make a better one, this should work. And the only thing left to do is to replace this here with this. Okay. There we go. Next, what do we have? Okay, so type alias info, which is this. Identifier has a shrink instance. List of identifier has one. We can use that directly, which means shrink of a type alias info that has 3. I guess I could make them generic and then use a generic definition of shrink, but I don't want to make those types generic because there's no other benefit to that. So this is going to be name, params, and value. And the result is going to be a type alias info constructed with one of the many values of shrinking the name, shrinking the parameters, shrinking the value. Oh, wait, there's a downside to this. There's a downside to this approach, which means if any of the things cannot be shrunk, then I'm gonna return nothing for all of this, despite the fact that I could be shrinking the other things. I think there is an example of not. I think there's an example in the documentation of not to do this. It will force quick check to shrink XL. Yeah, that's not what I should be doing. Okay, so I need to revise the places where I've done that, like here. So this would be, instead, the concatenation of doing there we go. I try shrinking one of the two lists, I try shrinking one of the others, and I combine the two resulting lists. And that gives me, that will always try to shrink at least one of the two of them. And if any shrink returns empty, we just ignore that branch. And that way I'm only trying to shrink one branch at a time. Okay, it's gonna be the same thing here. I'm just gonna duplicate this at first. Go, and here we only shrink the first branch, or we only shrink the second. Here we don't have any problem because we are using shrinking properly on the thing. Here, likewise, we don't have any problem. We don't have any problem here as well. Here, however, is where we're back to having to be careful. So we're gonna have to have 3 this time. And here we only shrink the first. Here we only shrink the last. Okay. Next, what do we have? An enum info, which is just two things, so that should be easier. Shrinking an enum info that has two things, which is name and values, is going to be there again, a concat of we do an enum info on shrinking the name. Hello, how are you? I'm finishing what we had started on Thursday. We're trying to do like a test where we generate an arbitrary AST, pretty print it, pass it back, pretty print it again. And last time I was trying to take shortcuts because basically this means debugging three different parts at the same time: the pretty printer, the parser, the AST generation. Well, four if we count the arbitrary AST generation. And I wasn't arriving at something satisfactory on Thursday, so now I'm taking the time to do things properly. But yeah, I'm doing fine. Thank you. So here I am manually defining a shrink value for all of the arbitrary instances, which is used by QuickCheck to try to reduce, okay, we've generated an arbitrary test case that breaks. How do we reduce it to the smallest possible test case that breaks? And that's basically how do we decompose a value that we know is broken into a smaller value that might still be broken. So it is a bit tedious to do it manually. There are, of course, things in QuickCheck to generate it for us. But the ones that are very convenient, like the generic shrink, require defining a generic instance on all of my types, and I don't want to do that. So instead, I'm just defining the shrink values manually. So here, I could write it differently, but I like the symmetry. Either we try shrinking the name or we try shrinking the values. And if any shrink operation returns an empty list, then that branch is ignored and we concatenate the result. Okay. How do we concatenate? How do we shrink a struct info? That is three values. So we're gonna get back to this logic here. Just gonna copy all of this. So we shrink a struct info that contains the name, parameters, and values like so. Okay, so that's struct info done. Now, const info hopefully should be easier. It is also three things, so I'm just gonna copy this. We shrink a const info that contains a name, type, and expression by doing exactly this: const info, const info, const info, and its name, C type, expression. Okay. So that's how to shrink that. Next, oh, 5 arbitrary on this one. That's gonna be big. Let's do that. So here, although I guess I could try to do. No, because I want to not shrink. I was gonna say I could try to do a combinatorial of shrinking all of the first one, then shrinking all of the second one, but no, I want to not shrink one of the branches when I shrink one of the others to make sure I don't shrink both at the same time. Okay. So let's do this the ugly way. Can I do this in a slightly less ugly way? I can probably rewrite this to avoid using this syntax for something this big. So I'm trying to shrink a function info that has a name, parameters, arguments, return type, and a body. And what I want to do is concatenate 5 different lists. The first one is we shrink the name, but the rest is unchanged. For x in shrink the name. Yeah, this is probably a bit more readable than this version. I might change it afterwards. And here we keep the name the same. It's the parameters we change. Here it's the arguments we change. Here it's the return type we change. And here it's the body we change. Actually, if I don't name them this way, I can align things vertically and reuse them more easily, but no, I think it's better to keep it that way. Okay. Yeah, I think this is better than this version. I'm tempted to rewrite this as a result. This is const info x c type expression for x in shrinking name. And we do that 3 times. And this is name. Yeah, I think this is better. In no small part because it is a bit more, like the structure is a bit more visible, I think. Still align. I could, yeah, no, I could. And yeah, it's not a bad idea. I could do that. We were talking the other day about vertical alignment, and the big downside of vertical alignment is that it makes diffs, it can mess up with diffs, basically. But since I'm the only person working on this project, I don't mind, and this way the structure of what's happening is a lot more obvious. Okay, let's do the same thing here. I'm just gonna copy this time. So it's name, params, and values. Yeah, the thing is, like, as we were saying last time, on a project that has more than 2 people working on it, I am strongly in favor of having a very, very opinionated formatter and never caring about, like, because consistency is and reducing diffs are a lot more important on a project that has a lot of people. But since I'm the only person working on this, then this makes the structure a lot more visible, and I really like having like this visible structure in the code. Okay. And there's only one last, I think. No, there's a few more. I copy it here because it's almost the same thing. name params values, except it's values singular, but otherwise it's the same thing. And those are type alias info. Okay, and I think this is no. There's one more. There's another one here. Okay. This is module X declarations for X in shrink imports. Shrink is part of arbitrary. So arbitrary is this type class that is part of quick check, which is basically how do we generate an arbitrary value of that type to test properties, such as like for any value of that type, this property should hold. And shrink is, okay, we found a test case that breaks. Can we reduce it to something a bit smaller for error messages? And it's basically given a value that we know breaks the test, how do we shrink it? How do we create a list of smaller values from it to try to find one that is smaller that replicates the behavior? Which is going to help a lot with error messages, because a thing we were struggling with last time is, okay, we're generating extremely large ASTs that are broken, which means the error message is absolutely gigantic, which doesn't help us figure out what's wrong. Yeah, it is a property-based testing framework. The only annoying part is having to define for all of those types, okay, how do I generate an arbitrary value of that type? And the fact that it is a type class also means that like there is one way of defining arbitrary values of that type, rather than having like a different function per kind of test. There is another library for property testing called Hedgehog, which, if I remember correctly, is better at that because it allows you to specify the function to generate like the arbitrary values rather than tying it to a type class. But I haven't used it in a long time. I could be wrong on this. But yeah, what we're doing here is, like last time we defined how do we make an arbitrary value for property testing, and now what we're defining is, given a broken value, how do we try to make it the smallest possible test case that breaks? And again, I could be using the generic declaration of shrink, but yeah, I've heard of falsify and I haven't tried it. One small constraint here is I'm limited to what the tasty library has support for, which I'm sure I could manage to make falsify work with tasty, which is this library I'm using that like organizes all of my tests, and it has bindings for a bunch of things, but not for all of them. If I look here, like tasty has HUnit, which I use, golden, which I use, quick check. It has hedgehog, but I don't see falsify in that list, which doesn't mean it doesn't exist. But as a result, as my starting list of like things I wanted HUnit for basic unit testing, golden for golden tests, and quick check for property testing, basically. On top of that, I'm using the tasty autocollect to try to never have to declare a list of tests myself. It just at compilation time gathers all of my tests and generate the full test suite at compile time, which makes it a lot easier. But yeah, I've heard of falsify. I haven't tried it. Okay, so we're missing here, just here, this one, which is going to be X and I type for X in shrink of the I path. And the same thing for X in shrink of the I type. Okay, now this should be good. My Emacs feels a bit laggy for some reason. Oh well. At least since I'm no longer running OBS on this laptop, if it's a bit laggy, that's fine. Okay, so here we are done. Here we are done. Function, we are done. Now, function arg type, what's that? Okay, so that's going to be pretty easy to shrink because we have only two constructors. And if it's a by value type expression, then shrinking this is just applying the by value constructor on all the values of shrinking the type expression itself. And if it's by reference, it's exactly the same thing. Okay, next, what do we have? Next, we have a statement. I think here, since most statements delegate their information to like an info type on the side, this a tiny bit, I guess, for the stream. I can do the same thing I've done before, which is delegate the responsibility of shrinking to the info type. Which means there we go. And anything else, which means either it's a continue statement or break statement, there's no way to shrink them any further. Anything else just returns an empty list. And now I just need to copy the constructors here. Okay, there we go. So that delegates the responsibility of shrinking the thing to the if info or any of the others. And not touching the debug, the location, because the location isn't really used for anything. And I'm always using the same debug location for all of them anyway, so it's not important to shrink it. Next, how do we shrink an if info? And that's gonna be, we're back to the same thing. We have an if info that contains an expression, the body, and the excuse me, the else case. How do I call that? Like that. So it's gonna be the same thing again, where we create an if info with a new value, and we keep those identical by trying to shrink the if expression itself. There we go. And then trying to shrink the else case. Okay. Next, what do we have? An else info, which again we can delegate. We can delegate shrink to the info type within. So if it's an else if of an if info, then the result will be an else if on shrink of the if info. If it's an else block, which contains a list of statements, then we can do the same thing. We apply else block on shrinking the list of statements. Okay. Next, what do we have? Next, we have the for info. which seems to be fairly similar. So this is going to be shrink of a for info of a name, an expression, and a body. It's going to be a concatenation of those three things. There we go. That should be all we need. Here, name, expression, body. And I think while info is the same thing, but we've not even, yeah. Okay, it's even simpler. It's just an expression and the body, which means I can keep only those two lines and remove the name. Okay. And those are a while info. Next, let info, which has three things. Let's copy this one. What the hell is this? Oh, it's an April Fool's prompt on Twitch. Thank you very much, Twitch, but no. Okay, so a let we have name type expression. Okay, there we go. Next we arrive at expression. That's the big one. Yeah, I mean, some companies still make some fun stuff, but yeah, I think that there's enough misinformation already that we don't need to add more. The board game arena one was quite fun. Their joke today was a big new announcement that they're starting a new thing, which is in real life board games, which is just like online board games, but like around a real table with real people. And the fun part is they announced this, and then the site crashed, which means you couldn't play games online. So it was kind of funny. Now, how do we shrink an expression? And I think it's one of those cases where we can do the same thing of basically matching this like constructor and just shrinking the arguments. Basically, I think we can do that. I think it's the best case. That's the simplest way to do this. The only thing here is, do I want to also I had a problem last time as well, which was like the size of the things we were generating was pretty big. And I have this thing sized here where I divide by 100 every time, but it was still pretty big test cases. Is this enough, or do we want, maybe for statement as well, I want to really, really reduce? Ah, that's the thing. I have here the arbitrary, but I don't have. Yes, here I should also do the same thing. I'm gonna do that quickly. So here this should be a sized statement. How did I do that for expressions? Okay, and otherwise, if it's not 0, then I do a scale. Okay, let's do that. So if we're trying to generate a statement, but we are as that says 0, then we do one of the statement that is not recursive, which means basically a continuous statement or just a break statement. And I think a break statement of, yeah, just this, I think not even one of, it's just gonna be, there we go. If we are at size 0, we don't want to go any lower. The only statement we generate is a break statement. And otherwise, we scale divided by 100, which is pretty ridiculous, but that should, it might be too much. Maybe we're gonna need to size less than this. But for now I would rather err on the side of um, generating small test cases and hope that they work. And when we've confirmed this, then increase this a tiny bit. And that way, if we go recursively, yeah, that should be fine. Okay. And I need, I think, to put the shrink here. I think the where block is going to be on the instance. We'll see about that. Okay. And now for expressions, we need to do the same thing. I need to define shrink. Oh, it's the alignment is a bit different. Which one do I want? Okay, if it's defined like this. Actually, I'm not sure. Let's try to compile and see if it works or not. Okay, small syntax error. Okay, so here the where statement needs to be indented, which means it needs to be within the definition of arbitrary, which means the shrink needs to be after. Okay, so that's going to be the same for expression, where we're going to need to define the shrink independently. Okay, so let's copy this gigantic case. And let's do this on a case-by-case basis. But for almost all of them, this is going to be... Oh god. Given some location that I don't care about, and given some arguments I'm going to have to name later, because not all of them have the same amount, but most of them it's 2. Let's say E1, E2 by default. This is going to be applying the constructor. For most of them, actually, it's going to be a reduction. It's going to be the same thing of trying both cases. So it's going to be the constructor applied to x e2 for x in shrink e1, concatenated to constructor e1x for x in shrink e2. Okay. Now let me zoom this out a tiny bit. It's going to be a bit small on stream. I'm sorry about that. I'm going to keep it short. But just to be able to see what I'm doing. So I'm going to move negation expression above this, I think. Where would it need to go? After reference would be perfect. Okay. Because here's subtraction, addition, subtraction, multiplication, and so on. Oops. I think all of those, the thing I've written here, except for the constructor name, are correct. Actually, it's never going to fit in one line. I think I'm going to remake it on the second line. because this is gonna be pretty monstrous. Yep, this is monstrous. Yeah, this is unreadable. Let's reformat this. I'm just gonna say that after an arrow is gonna be a new line. Okay, and next. Could automate this, but it's fine. I'm gonna do the same thing with the concatenation operator. After a concatenation operator, new line. 2, 3, 4, 5, 6, 7. That's one too many. Okay. Let's do it again. There we go. That's a bit better. We shrink an addition by trying to shrink the first argument or trying to shrink the second one. Likewise for subtraction and all of the others. Okay. It's a bit... Yeah, it's a bit inelegant, but I guess it works. Okay, next. We have the rest of them to do. A path expression is a lot simpler because there's only one argument. So, a path expression is gonna be just a path expression with this of shrink the path info. The field access expression. Oh, was this what was wrong last time? I don't remember. There was a thing in which the AST was too generic and it was allowing things that made no sense. And we ran into some issues. I don't remember what it was. I guess we'll see what errors we get. So here we have, in the case of a field access expression, we have two arguments. So we are going to want to keep the same thing, where we have a field access expression for this and a field access expression like this. A call expression. That's a path info indeed. That's correct. So it's going to be the same thing. So I guess I can start putting them here and aligning them as well because they are using a similar structure. I can just rename them this way. It's a bit... And align them as well. That way everything is consistent. Oh, and I need to not forget... I have forgotten it everywhere. Okay. That is annoying. That is extremely annoying. Okay. So here we are gonna want to replace... So either x followed by e2 or e1 followed by x with the full string, but the debug information first. Okay. There we go. So field has two things. I'm going to keep it the same. Call expression has the same. I'm going to keep it here as well. Array expression has only one, but index expression and struct expression do have two arguments as well. So I am going to move them here and do the same thing as for the others. This is a call expression. And I'm going to align it with everything else. And let's not forget the debug location. Okay. We're almost done. Index expression. Okay, and then struct expression. Okay, so that's all of the ones that with two arguments, which are all the same logic. And now we're left with array expression, Boolean literal, int literal, character literal, string literal, reference, and negation, which all have only one argument. So we can just rewrite all of this to be instead all of them is going to be the constructor and the debug location applied to shrinking the argument. And now I just have to copy the constructors. There we go. I can align this for readability. And since here this is a separate group, I'm going to vertically align it on its own. Okay, so now that's how we shrink expressions. And hopefully by now we're almost done. The last thing is how to shrink a path information, which is a thing of two arguments. So it's going to be simply shrinking a path info of a name and parameters is going to be the same thing we've done a few times right now. A list of a path info with some x and the parameters for x being one of the values when we shrink the name, and path info name x for an x when we shrink the parameters. Okay. And now that should be all of it. Let's try to compile this and see what broke. Illegal term level used, and I see function, so it's probably a function info that I have called function. Yes. Okay. Shrink body doesn't exist because it's called expression here. Are we missing anything? We are missing a few things. Oh, non-empty doesn't have an instance. That's fascinating. How do we... Oh, that's interesting. I didn't expect that. Okay, so let's make an instance for non-empty, I guess. That's almost something that we could want to like patch either quick check or non-empty to like add. 'cause that's a missing instance. So if we have an arbitrary A instance... Oh yeah, here indeed, to generate an arbitrary instance of... I do create an arbitrary non-empty list, and then I make it into a non-empty list. Fascinating. Okay, I guess I can make just a generic instance of arbitrary non-empty of A, which is going to be... Making an arbitrary non-empty list is going to be exactly that. That's... Given that we can make arbitrary values, I make a list of at least one, an arbitrary list of at least one arbitrary value of type A, and that list being non-empty, I can just create a from list with it, which will crash on an empty list, but we are asking QuickCheck to generate a non-empty list, so that's fine. And how do we shrink a non-empty list? Well, I guess every non-empty list is an X value at the beginning. I guess I could make it into a list, shrink that, and then try to make a from list. Yeah, I think I can do that. So given some arbitrary non-empty list NE, I'm gonna do a map maybe of NE, and it's not gonna be from list. I saw that module being already open. There we go. Because from list is the one that will just crash if it's wrong. Oops. What I want is non-empty that will try to make a maybe. So if I do a map maybe, it will only keep the values for which we succeed. So it's going to be a map maybe of non-empty of shrinking the list. Okay, so we have a non-empty list. We make it into a list. We shrink that. And for each value in the resulting list of lists, we try to create a non-empty list, and we only keep the ones for which we succeed. Okay? Which means now I can go have a look at all the NE here and replace them with arbitrary, because now we have an instance of arbitrary for non-empty. Okay. Yes, this needs to be an F map, since list of one returns an non-empty within the generation monad, so we need to F map this. Map may be not in scope, that is going to be imported from data. Is it list or maybe? I think it's from list. Let's check. No, it is from the data maybe. Okay. I'm surprised that it's actually not part of my prelude. I'm almost tempted. Yeah, I'm tempted to add it to here, map maybe. Because there's very few cases where this is going to result in a conflict. And it's always a useful function to have. My hope as well with like the conversion to list and then back is that list fusion will, like, the compiler will be able to apply list fusion and realize that we are only using list as a intermediary step and just combine all of this and avoid doing a bunch. Okay, there we go. Now we are running tests. And last time a bunch of tests broke. Like, it was non-working, which is fine. We welcome non-working tests, but at least now they should not work in a way that reduces and give us something useful. The only thing is, I've tried to improve the arbitrariness to avoid generating too many things, but we're still already taking 60% of my memory, so maybe I'm gonna have to kill this before it kills my computer. In the meantime, I can go back to the AST because the pretty printer we worked on last time, there was one thing that was wrong with it. And if I remember correctly, it was the optional things like parameters that were not aligned properly. Okay, it seems to be constant at 60% of memory and not go over that, which is a lot, but should be 61%. I'm gonna let it run for now. No, it makes my Emacs unresponsive. That's becoming a bit of a problem. I don't know why the tests are being so big. I've explicitly made them small. Okay, no, yeah, I'm gonna need to kill them. This old laptop has only 16 gigs, and it's soldered RAM, so I can't even upgrade it. But only 16 should still be fine to, like, do the kind of stuff. So I wonder exactly what's wrong. Huh. Why is it not... I might have to be a bit more aggressive. Okay, well. I guess I could, for the sake of this... Basically keep this one and remove this one. So expressions are always going to be, for now, literals, which going to be a lot simpler. Will that be enough to make smaller test cases? Aha. So here we already have things that break and are much smaller, which is nice. Okay. So here, what do we have? Aha, so here we are shrinking our import paths in a way that is incorrect. And that is because here, when I, here, yeah. Here, basically, when I have generated an arbitrary identifier, to shrink them to have a smaller test case, I shrink it back using the list instance, but this might give me an empty string. So I need to keep the ones that are not... not empty, basically. Okay. Okay, so we still have some errors there. What do we have? A struct declaration. Haha. So here, if we look at the parser for a struct declaration, okay, so a structure cannot be empty. That means that here our test has found a case where the type system allows the representation of something that's wrong, which is always good. Let's go back. So we've said that when a struct is declared, it must contain field values. And here we have a list which can be empty. So if I make this a non-empty, now we have something that should be correct. As in, we cannot represent an invalid struct info anymore. Which means, however, that we might need to change the way, because now this $5 is going to be a comma list of struct field. Here, this is going to be, I'm going to need to make this a non-empty list, which is going to be from list. Okay. Except I can't type apparently. Close sub. So here this is the prettifier. What is wrong with this? Here I'm gonna need to make it back into a list for the purpose of this. And I'm gonna need to have data list non-empty in scope qualified as NE. Okay. I actually want to fix some things in the pretty printer, but for now, since the test is giving us some things that are broken, even with reduced expressions. Aha. So let's go back to here. I never have. Ah, yeah, here I have actually just, okay, so I'm just gonna add this as well, qualified as an E. Okay, next. What do we find that's broken? With no expressions for now. That's fascinating. How are they getting so big when I'm not generating any expressions? I wonder if it's just generating like thousands and thousands of declarations. Maybe I should just like scale down the modules. Yeah, this is gigantic. Okay, yeah, I'm gonna kill tests again. And it's not dying. it's the thing is like I have made sure that in the two cases that are self-recursive, I scale down. So here in the two places that are self-recursive, which is statement and an expression, I have used the size thing to make sure that we reduce the size. However, what I'm guessing is a bunch of those things are even if there's no self-recursion, like a module contains declarations that contain info things and there's no like self-recursion that can go infinitely deep, there's still lists of lists of lists which can probably go big pretty quickly even if there's no self-recursion. So I should probably is there actually can I try something else? Here in arbitrary, I was looking at. Actually, let's go back to the top level documentation thing. I was looking at scale. Is there a way to just resize? Yeah, if I what happens if I force the resize basically? So here, what happens if here when I do arbitrary, I force a resize of size 2 of this? Will it work? Yep. Well, at least it found something that breaks absolutely immediately. Aha. Is it the case again? Where we should have a non-empty. Let's see. Oh, there's also the possibility that we have a shrink instance that's wrong, and therefore we have an infinite recursion on like trying to shrink something and we never actually shrink it lower. I don't think that's possible because we always use the list instances underneath, but it's probably worth a check if we continue having issues despite the resize. Okay, so here, what do we have? We have a use tree, a use statement in which, yep, this list cannot be empty as per the parser here. What does our grammar say actually? Does it say anything or are we free to decide? Let's see. It says to do here for records. Perfect. That's very useful. Apologies. I need to quickly fix that. There we go. Sorry about that. And here I have not specified either, but in the grammar that I had written, which was like a temporary one, yes, this was always a non-empty list here. And for a structure, this was always non-empty as well. Okay. So this seems to be consistent. So our parser here is making it non-empty. And that means to be consistent, we need to fix our AST. And here, for an import type, this is a non-empty list of identifier, which should be fine for most cases. The only thing is here, this is 1, 2, 3, 4. I need to make that into an empty list. Okay. One more case where we found where we found something where the AST type did not represent correctly what we wanted. And here in the prettifier, we have again the same problem. And that's gonna be a... Can I make that a fold map? No, I don't think so. I could probably make that a fold map, but I would need to create a list from it, which would not be any better. Okay. Okay, so let's see if this round trip finishes quickly. Oh god, what is this? What the hell is this? Aha, this might shed a light on how we get such an absurdly complex... Because this is a module that has no import and has a declaration which is one constant here, which has one const info, it's named A, and its type is... That's a recursion for which we don't have a scale. The path info... Yep, this is a recursion where we don't scale down. That's the issue. That's the problem. Let me show you what I mean. Here is how a path info is defined. So anything that is a path to a symbol somewhere. It is a non-empty list of identifier and optionally some type parameters, which is like in a list, the types that are the arguments. But the type is itself, a path info. Because, well, maybe my A of B of C something, its type argument, is also a type that comes from that same module, which means it may have itself a type parameter that contains a type, which may have type parameters, and so on. This is a self-recursion for which we don't scale down, and I think this was the source of our problem. So that means that here in the arbitrary instance, here, this is one of those places where I need to do something like that. And if we are on a small size, then I'm just gonna say that it's a path info of an arbitrary it's fine for the non-empty list to be arbitrary. So I'm gonna rewrite it that way. But with an empty list of type parameters. And if we have any other size, let's do the same thing I've done otherwise, which is a scale divided by 100. Of that. Actually, I wonder if the scale here would just be enough to always reduce the list. Maybe this case is not really required. That's fine. Okay, so that should give us something that's already simpler. However, we do still have this bug to figure out. How do I get an if keyword from this? Fascinating. Huh. Okay, well, let's try that again. Except, of course, it's called path. Oh, I hadn't seen your message, sorry. A PR someone submitted. What do you mean? Sorry, I missed your message, so I don't know exactly when you said that, so I don't know what I was saying at the time. Yes, this needs to be pure empty list. Ah, yes. Okay, so now this should be a bit easier to read. What do we have? Aha, that's an interesting problem that I had not considered. The Here we generated an arbitrary function, the name of which is in. The problem is that in is a keyword which is not allowed. So that means that we need to revise our identifier generation to not generate things that are keywords. That's gonna be fairly easy to do, given that all our keywords are lowercase. I guess the simplest thing to do I like the idea of having this. I guess I could do something like this. So it's a list of at least one character that is guaranteed to be a letter, such that not a keyword. So that's not LM keywords. That does, however, imply having. Yeah, I guess it's not a bad idea. You're right. Rather than trying to reject any keyword, I could just prefix any. Yeah, you're not wrong. I can do that. I can instead do, therefore, a list of arbitrary letters and prefix that with. So I can go back to this. And here I can prefix by underscore, which is a valid first character from an identifier, which means our identifier will always be. Aha! But this is where we run into a similar problem. Our shrink will probably try to create identifiers. So that means I should do a shrink that's slightly different for identifiers. Let's have a look at data text. Is there an init function there? As in, yep. All but the last character. Which must be non-empty. Okay. It's never gonna be. Okay, so here I can do that. Shrinking some identifier I, which is gonna be text. If so if it's already one character long, I guess I could even do that if it's just. Actually, no, because that's a string literal, and I don't think. No, I do have overloaded string, so this should work. It's fine. Otherwise, we just reduce by doing a t init of the identifier. Basically, when we try to reduce an identifier, we just shrink it by one character, but we never shrink it to 0. And since we only remove the last character, we never remove the underscore. Therefore, we are not going to be generating identifiers that are named like a keyword. Okay, what do we get here? We get const underscore underscore equals. Okay, so here I think the problem is we are generating a character that we don't know how to parse back. Because the show instance on the character is using a syntax to represent characters, which is not one that we know how to represent. So let's have a look at our arbitrary literals. Aha, yeah, I'm using a different definition here. I was using arbitrary character and string literals here. I don't like the idea of generating arbitrary ASTs in which the literals are not exactly like, not are a subset of the range of what we would accept. That feels wrong, but since there were still a few things that we had not done in Alexa, I might do that for now. As in, I'm going to copy this. Character literals are arbitrary such that is letter. And such that is letter. I think is letter is more generic than is lower and therefore a bit better. I guess is print would probably work. It depends on how the show instance is lower is no longer used. Okay. Okay, no, that doesn't work. We have the exact same problem here, where we are generating a character which is not. Okay, so how should we handle this? If we wanted to handle this properly, we would need to test whether our pretty printer would need to test whether the character can be represented as only one character, and otherwise, if it cannot, represent it as a backslash something using one of the codes that our Alexa supports that are Okay, so I think for now I'm gonna use just is lower, and I'll make a note to go fix this at some point. Oops. So in this, replace is letter with is lower. There's a bunch of issues we need to fix with our pretty printer at some point. Okay, let's see. How does that work? Okay, so now this passed a round trip of 100 tests. So it generated 100 different cases. This time it did find something that's wrong. That's again. What's this character? That's 43934. Huh. Could it be that we're not... Oh, yeah, okay. Yeah, I don't know what this character is. is there a way for me to detect that a character doesn't have a proper representation? I don't know. Let's have a look at data character. Okay, so lower, just like a letter selects from any Unicode code point that is considered a letter, which means it probably supports a bunch of things for which the show instance will use this syntax with the backslash, which is not a syntax we support. I could use is ASCII lower instead for now, but it would be a lot better. Yeah, I don't think there's an easy way for me to test whether the show instance actually. So I guess I would need to use the show instance, and when it's something where we cannot represent it with only two characters, then figure out the way to transform that into the proper Unicode value to use the Unicode escape code. That's a lot of work. That's something we want to do at some later point. It's something I'll take a note. I think for now, let's do something a bit easier. And let's do an is ASCII lower. Okay, let's try that again. Except, of course, I didn't import it. Okay, we still found something that's broken. Huh. Parser error, keyword use. Huh. That's fascinating. That's not. Our Lexa claims. That seems to like a pretty big bug in Alexa, if that's true. That's interesting. Let's see. How is that possible? This, the Lexa gave us a T keyword use here for this. Okay, let's try this in GHCI. Let's just reload GHCI. So this was lexed wrong, apparently. Um, what's the result? Oh, yes, of course. Okay, so what I'm gonna want to do is I'm gonna want to traverse this with a traverse print. Okay, so here we have this type declaration that for a name that is just underscore and with type parameters which are just this thing, I associate underscore. This is lexed wrong. So type identifier underscore, that's correct. Operator less than, I guess that's true. And then T keyword use. This is sparse as use. That's fascinating. How does that happen? Is that an artifact of the way we pass identifiers? Huh. Okay, well, we found a big bug in Alexa. Because I don't... Like, the only case where we create a T keyword use is when we encounter the string use, and I don't think it has to be followed by either a white space or a symbol. Let me check the Alex documentation quickly to check that this string thing here is the correct way to describe this. Let's have a look at an example. Aha, for the strings, they don't... Okay, so what does that mean to put things into strings like this? Well, matches the sequence of characters in the string in that order. I don't know. Like, let's see. If I change use here to not be defined with the brackets, and I recompile that, okay, the same problem arises. So that's not the problem. How does that happen? Do I have literally any other case of something? No. Okay, we don't. So I guess that when we pass an identifier, we must mess something with the internal Alex state. So this is an unfold M of Alex read identifier character, which is a helper function, which I think is defined in here. Which is a get matching character. Now, that's a good suggestion. However, here I see that like the in the randomly generated AST, the alias parameters, there's only one parameter named underscore se, which matches with this. And here, when we try to lex that, we lex that wrong, despite the fact that the word use doesn't appear. And I don't know how that happens. There is a non-zero chance that this could be a bug in Alex, but I'm not going to jump to that conclusion just yet. There is something that's definitely wrong, however, which is that we should pass this underscore SE thing as an identifier, and we don't. So here what we do is we look at the remainder of the input. If there is more than one character left, if the first character is correct. Oh, could it be? Could it be that here we don't update in the state? Haha, this could be it. Our passer state is an input, which is some text, a location, the previous character, and then a bunch of bytes. The assumption here is that when we are reading a character, since we're trying to match the next one, the assumption is that the previous bytes are empty. What if it's not the case? What if it's not the case, and as a result, but even then, that's weird. We should be returning. Something is definitely wrong. Wait, no. We don't even try to read this as an identifier. We always match keyword use. How is that possible? If I put a space here, no. Why are we matching underscore SE as use? Would we match underscore N as in? No, we don't. And enum? No, that's indeed matched as an identifier. Let, if I try underscore ET or something? No, that is indeed identifier underscore ET, that's fine. How on earth is underscore SE perceived as keyword use? How on earth? Okay, I want to try other ones. I don't even think so, because it means, because in this case, we don't even try to pass this as an identifier, which means we don't even reach the identifier case. So this matches use and therefore doesn't call identifier. That is. No, const doesn't. Like, is there any other letter that it could replace? No. Like, is it the letter U in particular that poses a problem? That if I do this string here as keyword use, No. So there's something very specific about this that breaks. Huh. Okay, there is one thing I have in mind that could be the cause of this, which is the part where we break a. It's not gonna be here. It's gonna be in there. In get byte here, where we decompose UTF-8 something, which is a function which is defined in internal encoding. So if I decompose UTF-8 underscore, it just gives me 95, which is indeed underscore. I don't understand what's happening here. The fact that I can't seem to replicate this with literally any other keyword is mind-boggling. There is no other case where we pass. What the hell? That being said, I did see something somewhat similar earlier where like a series of letter was interpreted as the wrong thing. But I don't know if I would be able to replicate it. That's the keyword use. And this passes as the keyword use. Let's try. That's a good point. That's a good point. Let's try that. Oh, just passing this on its own didn't work. That's interesting. Okay, so why did passing this on its own not work? Interesting. So just lexing one thing on its own doesn't. Oh, because yes, keywords are not valid unless they're followed by some kind. So here I would need to have this. Okay, t keyword const use underscore se is parsed as keyword use. What the hell? What the hell? Okay, well, one thing I can try is I can check that we don't end up in the case of the identifier. No, it doesn't, is the thing. Oh, use, actually. Yeah, I've tried the first letter, but I haven't tried the U. That's a good point. Do I have any? Yes, I have return. So return, keyword. No, it doesn't replace the U in return. It doesn't replace the underscore in return. Doesn't replace the E in return. But it replaces the underscore in use. Oh, how on earth? There's something I want to try, which is here. Basically, I want to just have an undefined, like just error, like here, the very like ugly error. I want to check that here. Yeah, no, we don't enter the identifier special case. This is this looks like an Alex bug. Huh. Like, does the order matter? Can I, if I put it first? Nope. Oh. Oh, that's ah, damn it. That's the thing where like when I do recompile here, it does not recompile properly. So there, every time I've made a change here, it did not get reflected properly. I need to recompile first. Okay. So of course this is broken. That's fine. And here, okay. So now if I try to, okay, now it breaks on this because it's trying to pass it as an identifier. Okay, now it breaks on this again. So if I put it back here and I remove the error here, force a recompilation here, force a recompilation here, that's use, and that's still use. But it seems that we did and we did come here. That seems unlikely. It is not. It is not an April Fool's joke on my part. I will say that. So recompile here. To recompile here. No, no, we did not. We did not enter this here. We did not encounter this error. So when we do this, it doesn't go through. Yeah, okay. We've confirmed it doesn't go through the identifier thing. Huh. Let's try just one thing. Because I think it was behaving slightly differently when I did this. So let's recompile this. Oops. Reload that. And now it gives me the exceptions. Now it fails to pass. What on earth? Now if I go back here. And now it works. Changing the order in the file worked. What? What is this? What is this? Okay, no, I'm sorry. I don't want to move from this. I want to understand what's wrong. Because that seems cursed. So if I put this here again, so I've just changed the order in the file, which is a list of statements. It should not have an impact. It's broken again. Okay. I want to figure out this. Let me find in it's gonna be okay, that's the file. Oops, let me make this a tiny bit bigger. So this is the generated Alex file. The thing is, I know that Alex uses like tables of characters to like make things go faster. I want to try to see if I can understand what's happening here. Alex accept. So what is again? So underscore is 95 and U is 117. I have no idea what those maps are. Ah, yes, but it might be in hex. There is an X function. Where is it again? Numeric.lens. Okay. Great, no. However, with text printf, I can do a printf, and what's gonna be? Is it this of ord of underscore? Yep. Okay. Okay, so it's 5f for underscore. It it appears in those big arrays that I don't know what they are. And for you, it's 75. It also appears in those big arrays of things, but not in the accept. Oh, I guess maybe it's the index in this array? I don't know. Something I could do, despite the fact that I don't understand how Alex generates a file like this. I could make a copy of this file. And then go back to our code and just do the change that works, which is to bring use here. Compile. And do a diff of the two Lexer files. Okay, so the order matters. This Alex accept thing is different. It is extremely different between our two files. And as a result, the Alex actions is as well. Because the Alex action 1 now is keyword use, while before it was the Alex action 17. Which is now first. Wait. Huh. Weird. Okay, so the order of the declarations in the file results in a difference. Let's have a look at their documentation to see. Alex will always find the longest match. I wonder if it's a matter of if there are still several rules which match an equal number of characters, then the rule which appears earliest in the file wins. This implies basically this implies that there's another rule that wins. Wait, no. No, when we move it earlier in the file, it no longer matches first. This looks like an Alex bug. Unless there's something peculiar about. Trying to think, but I don't see anything in there that suggests that the order would matter. Have we found a bug in Alex? I'm honestly tempted to just duplicate this project, create a new project from scratch with just Alexa, and try to see how much I can reduce to arrive at the same bug, basically. I think I'm tempted to do this. This is a big detour. This is not what this evening was supposed to be about. But if we found a bug in Alex, this is going to be a very interesting result. So let's try. I'm going to copy this into Alex debug. And now what I'm going to want to do is to try. I'll remove as much code as I can from this thing. However, what I want to do in this small separate copy of the project, I'm going to want to create a very, very small unit test, which I'm going to call keyword lex, something like this. And the test is going to be a trivial and the test case of this is going to be stages parsing qualified as P. And this is going to be a test where we do a p.lex of underscore se space. And this must be. Do we consider that the test succeeds or fails when it matches the keyword use? I guess I'd say it succeeds when it's. So it should be. This should result. I'm not sure this is the right. Let's have me have a quick look at H unit. Tasty H unit. What's the operator that I want? It might be a triple equal or something like this. I never remember. Test case, it just requires an assertion, which is a thing like this. And this is probably going to be defined. Okay, it's one of those. So I want at equal question mark or Yep. So at question mark equal actually. And the result of lexing this should be the same thing we had, which is just a T identifier of underscore SE. That's a single test. I mean, I don't know what's happening here. The thing is, I'm not trying to necessarily debug Alex because, again, I don't know the details of how Alex generate its like lookup map of characters. What I'm trying to see is how small we can make this project and still replicate the problem. Because if we manage to make like a very trivial like Alex file that breaks, then we can submit it as a bug report and let the people who have actually written the code to debug it. Okay, so that should be enough to have a test here. Now I'm just gonna go very quickly through this and I'm gonna delete a bunch of things. I don't need E2E or integration for this. I don't need unit encode. So the only thing left here should be unit keyword lex. Okay. So I don't need arbitrary, I don't need compile, I don't need locate. Here I don't need this project at all. I don't need this, I don't need this. I am in the right folder, I'm not deleting my uncommitted code. I probably don't need... if I go to Alex debug, liblang everything, I'm using the prelude for this, but I might not actually need it. Let's delete as much as we can, get on to a project that only contains the Lexa, and let's try to see if we can make a small repro case. So, what can I remove? I'm not going to remove my prelude just yet. What's in MISC? Oh, yeah, just the images for the project, which are not committed to Git. In this folder, they can go away. Okay. That's a bit more clean. And now here, I can remove... I need the internal encoding for my implementation. I can remove the batteries folder. That's not going to be used. In representations, for now, I'm going to keep... I need location and tokens for now, but I can remove... all of those files that are unused for now. So I only have location tokens. I was wondering the same, but if that were the case, we would have noticed the same bug with other strings, right? And the fact that the order in the file mattered, like there's something more cursed than just a solution like this here. Here, I'm also gonna do in the Alex debug here, I'm gonna remove a bunch of things. Specifically, I'm going to remove the executables. I only need the library. There we go. There's a bunch of files I can remove. Okay, and now, okay, I've removed the AST, which means I need to remove the parser as well. I had created all of those empty files to highlight the different stages of the compiler. We are not there yet. All of those can go away. Perfect. I thought I had changed the option to stop generating the HIE files, but they're still there. Parsing, I'm not gonna import the AST anymore. This is the right folder. Because I don't want the parser and I don't want this. I only want the Lex thing that only parses, that only calls Alex. Perfect. And now in parsing, I can remove parser.y and I haven't tried single quotes. We can try that. And the only thing I want to check is here in monad, I can probably simplify this. However, I'll probably do that when okay, so this should already be a lot simpler. Here, yes. Okay, yeah. Okay, so what's the output? Oh yes, it should be a write, because here our parsing here gives us, it gives us a tuple of location token. So here I'm gonna do an fmap map second. I don't care about the location. I guess no, I really don't care about the location. So if I apply this lex here, then on the right, on the either thing, in the case where it's a write, which is the case where it passed successfully, I want to apply map second to remove the location, and this should be, there we go. And of course, Lex requires a file name. There we go. There's no EQ instance for tokens. That's annoying, but in the case here, since this is a very simple project to do representation tokens, I don't mind deriving EQ here. Test tasty is unused. It works on this project. What the hell? It works on this project, not the other one. How? What the hell have we stumbled into? Here, if I do... What's the import that I want? I want the one qualified. That one. What do you mean? What do you mean? It works in this separate... It works in this separate project? Wait. Is it because I copied the version in which... Yes, it's because I copied the version in which I've moved use to the top. Okay. So here, now, when I move this here, it is broken. So moving it in the file breaks the test. Okay, so this... Okay, actually, let me do another test. I want to test... that when I pass use, then I do get the correct keyword. Because I suspect, yeah, there we go. With the single quotes, I don't get... The single quote don't work. It expects... it matches the single quotes. So when I use the single quotes, it does not recognize use the letters as the keyword use. If I use double quotes, then use is correctly passed as the keyword use, but underscore se is passed as the keyword use. So we do have a bug. Now, let's see how much I can remove from this file and still keep the bug. Like, would any change in this file remove the bug altogether? Like, no quotes. Let's try. That's a good point. Let's try. So no quotes, but still this. Underscore se is passed as use. Use is passed correctly. Underscore se is not. That is mind-blowing. Okay, so let me try to see what I can remove from this file and see what, like, can I remove the identifier case, basically? Like, we don't support identifiers. Since the code is never called in this case, that should be fine. Should be fine. Oh, wait, no, actually, it's not, because I'm trying to test the identifier thing. Wait. Wait, no. That single change made it work. Because here the test fails because it does not find a case that matches. So the lack of this test of this case makes it work. What if I remove those ones? Now it passes. If I remove handling comments, it passes. What the hell? What the hell? Like, if I remove the brackets closing? Okay, removing the brackets is still broken. Okay, let's remove this one. Let's try to continue removing some of them and try to find the smallest possible case. And now it passes. How am I going to make a bug report for this? I know that Alex uses a thing where it generates like lookup tables, and there must be something there where it like its lookup table is generated wrong, I guess. But without knowing exactly how Alex works, I have no idea how to make a test case that's smaller than this, basically. Can I remove this? Will it still be broken? It's not. That is incredible. How do we move on from here? No, the thing is, what I do with the identifiers is basically I want it to only match when nothing else matches. And since Alex always selects the longest possible match, I want it to only match one character, one byte, when nothing else has matched. Everything else should be handled. And when none of the other cases have matched, one character will be the longest match, and we can fall into the identifier case. And in the identifier case, since I'm dealing with Unicode data and no longer with just bytes, what I do is basically I ignore the match, I restore the previous state, and then I pass an identifier and I update the internal state accordingly, as if we had matched an actual proper thing. So that's why it's just dot. That this is basically my default case. But yeah, it basically this same file is correct or not depending on whether depending on like the order and the inclusion of rules in this file. Okay, what did I remove? What did I remove last? Wait, why is it passing now? What did I remove? What did I, what did I remove? Okay, no, it's broken. It's still broken. And if I just change the order of the two rules like this, it passes. Like, come on. This same file, and if I switch those two lines, it's broken. I'm trying to think. Is there even a chance, no matter how small, that the problem is with my code? How on earth would the order between those two lines change the way my code behaves? Something I can try. Because I want to be. Because if I open a bug report for this, I am unable to make a smaller test case, which is really annoying because that means I'm going to have to include this whole thing, which is a nightmare. So before I open a bug report with this, I'm going to want to make sure this is not my code that's the problem. So there's one last thing I want to try. Let's import debug.trace. And in this Alex get byte thing, which is the only thing I give to Alex, basically Alex, as far as it's concerned, its input is this parser state thing. And the Alex get byte is the one function it requires to, given the state, return maybe the next byte of the input and the new state of the parser. I am gonna rename this one Alex that get byte 2, and my Alex get byte function, which is gonna have the same thing, same type, is going to be I get the result of calling Alex get byte 2, and I trace show m the result, and I return this, which means we are only ever gonna show it whenever this is when there is something that we match, which means I will show the state of this thing after every successful call to Alex get byte. And now we can try to see what the difference is in our internal state, the thing that we added to Alex, to make sure that it is the same and that the bug is not in our code. Okay, so this is the one that's broken. So this is the first test, the one that's broken. The first time we call Alex get byte, we return 95, which is underscore, which is correct because we are, in this case here, the rest of the input is SE space. The previous character is underscore, yes, that's the one we had. And the bytes is an empty list because this is not a Unicode character, it fits within one byte. The next time we return E with an empty list of bytes. Sorry, there's only E space left with an empty list of bytes, and we return 115, which is S. And finally, our input is just space and with no parser bytes, and we return 101, which is the E. Then 32, which is the space. And apparently it's called 3 times, and I'm not sure why. I'm not sure why it's called 3 times. But in any case, it is otherwise correct. And the only difference here is that on the first one, we return 117. Which is U. And with parser input SE, and then parser input E, that's the S, that's the E, and then that's the space. Yeah, our internal state is consistent with. Wait, no. The internal state is like this. It seems normal when the thing is broken. The last test we have to do is this and rerun. Because now the test pass. Now we return 95, 115, 32. Oh, I guess the multiple calls to 32 as when in the identifier I try several times to see if the next character matches. Wait. There is a difference here. There is a difference here. I don't see. There is a difference here, which is I don't see the case of the E being returned. And that means that with just underscore S, Alex is like, oh yeah, this doesn't match anything. Let me just like go with the default rule, basically. Huh. And in the other case, we have the same USE use thing. Okay. Yeah, no. It is different, but I think it depends on just like how much Alex is able to determine that, like, okay, we've called two characters and none of them actually match the keywords, therefore we need to apply the basic rule. But I don't see any error in our code, basically. Which means that the next stage is going to be opening a bug with Alex. And I don't know how to make the test case any smaller because removing a single line makes the test pass, makes this thing pass. What time is it? It's already almost 11 p.m. here. I've been streaming for a bit short of almost 3 hours. Do I stop here and just open the bug report off stream? I might do that. I might do that. Because I'm also tempted to just look into the code of Alex and see if I can spot what's wrong. But the fact that I cannot even easily make a small test case because the entire thing. Oh, sorry. Let me zoom this. Which one? Sorry. In symbol. Sorry. Symbol. This is a percent, and this is a single quote. Basically, to be a valid keyword, this needs to be followed by something which is not an identifier, which is either a symbol or a white or some white space, basically. Yeah, the fact that again, changing the order of those two lines fixes it really makes me think that like this is not a bug in our code. The fact that I cannot make a simpler test case, however, is frustrating. And I can try again. Let's try to see. That's the last thing I'm gonna do on stream. Is let's remove a bunch of random lines and let's try to see to keep it broken as long as we can. But apparently, removing a single line makes it work. Ah, this one. Okay. I mean, it is kind of lucky that a random test from Quick Check found this, because otherwise we would have had some completely mysterious bugs much further down the line. Okay, so some lines can be removed. If I remove all of them, it works immediately. Which is why I'm trying, like, since my goal is to try to remove the yeah, now it works. Well, the thing is, like, removing some lines works, which really what makes me think that what I suspect the bug is, since Alex generates like lookup tables for efficiency, there must be a collision somewhere. That's what I expect, basically. Okay, that one still broken. I can remove that. Still broken. Perfect. Still broken. Perfect. Nope. Okay, so that one is load bearing. Okay, that one is still, that's still broken. Perfect. Like, again, the fact that like removing random lines from this makes it work or not work really, really suggests that something is wrong. At the very least, being able to reduce the scope of the tests means that like when we actually try to debug this or when I open a bug report, the smallest the test case, the better. Okay, so no, those are load bearing. I wonder if like there's a minimum amount of rules for the bug to appear, and therefore now that we've removed a bunch of lines, the bug is no longer gonna show up. Yep, it looks like now we've removed enough lines. So let's check it's still broken. Yep. can I remove some of the keywords? Yep. Nope. Yep. Nope. 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 What the hell? Okay, so this one is now it's still broken. Perfect. Remove this one. No, okay. Okay. This is not the most exciting, which is why I think I'll just finish. Yep, which is why my identifier rule only matches one character, which means any rule that matches more than one will always match first. Which means between dot one character and use three characters, use should always match first. And in fact, it will always match first. The problem is that underscore SE, which does not contain the letter U, still matches first, despite the fact that it has, you know, it doesn't match the rule as defined here. So I think the order is not the problem here. Or rather, the order is not like it's not the tie-breaking rule of the order that ends up causing the bug. I think it's the lookup map that ends up having a collision. Yeah, but no, I don't think that's the case because it would the only case where the order would matter is there's two different keywords that match and they both match on 3 bytes, and therefore we pick the first one in the order. I don't think that it's the tiebreaker code that ends up creating the bug. Oops, I need to restore this so I get back to something that breaks. Perfect. Return. Nope. Nope. Like here, the things I'm removing are 4 or 5 letters, and sometimes it still breaks. It is I am convinced at this point this is an Alex bug. I think we've done our due diligence in checking that this was not our code, and I am at this point fairly convinced it is an Alex bug. Let's see. I've tried all of them, I think, and basically I am only removing the lines that still keep the bug in. I think if I remove both of those, now it works. Ah, it's a good point. They end in SE, and if I remove either of them, well, yeah, but like, look at this. Both of them are here. It doesn't work. I remove while, and let's remove even equals equals. Oh, okay. Knights is broken. Let's try this one. Okay, now I've removed this operator here, and it starts working. Let's try, however, that's a good point. If I do a stack GHCI, and let's try parsing like this. No, this is passed as the correct identifier. Oh, and this is passed as... Wait, why did it work this time? Oh, yes, because I removed... I need to put this back so that it's back to being broken. Okay, now it's back to being broken. Which means if I reload here, this passes as use, but this passes as identifier underscore SE. We have not managed to find a single other set of characters that actually breaks. And removing random operators fixes the bug randomly. Again, I know that Alex uses like compresses tables to try to like do maps of things to actions to try to optimize processing. There must be some kind of collision somewhere. How? I don't know. But again, my goal is to try to see to reduce as much as possible the test case so I can open the bug report. Because at this point, I have no other choice but to just open a bug report because it's broken. Aha! I seem to be able to remove some more operators. Okay. And nope, that one I can't remove. Okay, well, I guess that's good enough for now. And we can triple check this. I want to be super sure of one thing. I want to make sure I do call Alex get next token. This is the one thing we haven't tried to debug. So this is the piece of code that actually calls the action associated with... No, no. I was gonna say maybe in the way I process identifiers, something goes wrong with the processing of the state, but that cannot be the case because I only call the identifier thing when I call the action, which means when Alex has told me that we matched the identifier case, which we only do if we don't match the use case. Yeah. I was wondering this. I know there's a bug in. I know that there is a bug in Happy where having strict data enabled can mess things up. So let's check how we have. So I need to remove the last change. What was my last change? Wait. Did adding an empty line here fix it? Or did I hallucinate this? No, okay, I hallucinated this. Okay. So we have the thing that's broken, and now let's try changing. In the options here, I'm gonna remove strict data. Nope, still broken. So that's not a matter of lazy evaluation. Basically, strict data is a language extension that makes all of the user-defined records have fields that are considered strict by default, basically. Function remains lazy, like this doesn't change, but when something gets committed to a struct, then it gets evaluated. It gives you the control. You can still force fields to be lazy if needed, but it is a pretty decent compromise in terms of performance, which is why I have it enabled by default. Well, I can let it removed since it doesn't fix the bug. Okay, yeah, I don't know how to make this bug any smaller. I don't know how to make this code any smaller. That I don't know how to reduce this thing any further. The last thing I'm gonna change is I'm gonna move everything into the same. I don't need happy anymore. I can probably reduce a lot of those dependencies because like pretty printer is probably no longer required. F write ID no, that could not be because I write the ID info thing. Nope, still broken. I'm gonna remove the debug.trace thing because it's verbose. So I'm gonna remove this function and rename this one back to AlexGetByte. Okay, still broken. What else did I want to remove? I wanted to. I guess it's not a bad idea actually. I could. I mean, yeah. I guess I could highlight this so that it's kept more than a week. Oh, actually, I'm gonna run out of space on Twitch. I need to fix that. But yeah, I could get a highlight of this and send it as attach it as like see me trying to debug this for an hour and a half as an attachment to the bug report. Yeah, no, absolutely. The only thing I wanted to add, I wanted to change one thing. I wanted to. Where's the common? Nah, that's fine. I can leave it that way. The only thing is, I am going to go to lib, and I'm gonna move. I'm gonna remove all the files that are not needed, basically. So I'm gonna remove the most basic stuff. It's fine. It doesn't change anything. Yeah, no, I don't know how to reduce it any further. I guess I could, I could move all the files. So let's remove. Ah, yeah. Let's move the only files that I actually require. So I only need location here and tokens here. And I'm gonna need parsing here and parsing monad here and lexer.x here. So now I have lexer location monad passing tokens. I can remove this entire lang file folder. I can remove this file here. Now, if I try to compile this, it's not going to compile because the name of the things are going to be wrong. Because now it's just going to be Lexa. Oh, there's something I need to check. It's the version of Alex I'm running. Because maybe I'm running an old version of Alex in which the bug was present and it has been fixed since. Okay, now this should compile. Nope. Missing home modules. What did I do? Did I break? Oh, encoding is missing. Okay, so I am going to need to bring back encoding. Which I can copy from the original. Okay, and now. Okay. And here, likewise, those are now location tokens monad. And I don't need debug.trace anymore. Ah, yes, and now in the tests, I can probably simplify there as well. Remove unit thing and just move it here. To make everything as simple as possible for the bug report. But even then, it's like 8 files and stuff because I changing a single line removes the bug. Okay, well, yeah, now we have what's the shape of this? We still have the prelude in common. I could try to remove it. Basically try to make sure, yeah, I could probably just remove it just to simplify this. We have the encoding thing I could inline within the monad thing. Location I could inline within tokens. Make file I can remove. Readme I can remove. And I can remove the weeder file. Actually, no. Well, yeah, I can remove it. Okay, and now that's still not small enough, but we're getting close. Okay, at this point, I'll just off stream tomorrow submit a bug report, I guess, because again, no, there's one last thing I want to check. So we're still in a situation where this is broken. Now, the thing I want to figure out, I'll clean further. I'll reduce the number of files. I'll remove the functions that are not used. I'll try to clean as much as possible to reduce the size before I submit. And also, I'll make like a GitHub gist first and ask on some Haskell Discord on which I am to see like, does anyone have an idea before I open a bug report? I'll do all that work. I'll talk about it next stream if I have some feedback. The last thing I want to check is, do I have a way? Stack version. Does it give me? Okay, it tells me the version of stack. Can I get the version of the packages that are installed? Okay. Haskell stack. List dependency versions. Stack. Okay. The version of Alex we depend is 3.5.2.0. That is the most recent version. We are on the most recent version of Alex in which the bug is. Well, that was an adventure. I really think we've done the due diligence in trying to make sure the bug was not in our code. Again, at this point, there's a tiny bit more cleanup I want to do. And then I guess I'll just open the bug. And yeah, we'll see next stream if I can continue working on the test or if I have to wait for a bug fix on Alex. That's going to be interesting. That's going to change some plans for sure. We'll see. We'll see how that goes. Yeah. In the meantime, I'm gonna go for the evening because it's been a big detour and it's getting late. Um, yeah. Oh, really? You've tried to run the? Do you mean that you've tried to run the tests and on the latest version and they fail? Oh, yeah, you're right. Actually, yes, you're right. That's interesting. That's taken directly from GitHub, which means if we go to GitHub, I mean, yeah, changing the order of rules is the way to make progress. But you know, I don't see. I just see builds passing there. No, I don't see any open issue that suggests a problem. Yeah, this is a absolutely incredible bug, and thanks to Quick Check for generating that bug because otherwise we would have never found it. Anyway, yeah, that is gonna be it for this evening because I'm gonna finish this off stream. I'll see you on Thursday, and we'll see if by then I have a bug open and some more data on this. And otherwise, we'll see how we make progress despite a bug in Alex. Maybe it will be time to rewrite the mega parsec, but I don't want to just like spend all of like months on the parser. I'd like to move forward. So maybe if I don't have an answer on the bug report by then, I'll I'll maybe work on the bytecode on Thursday or something. I'll figure it out. Anyway, thank you for tuning in. Sorry that this was not a lot of progress, but I guess this was fun to discover a bug in a like pretty significant library. And yeah, I'll see you all on Thursday.